Okay, welcome. This is 5.3, the fundamental theorem of calculus. Without an introduction, let me just give you that theorem. So it goes like this. Let f be a continuous function on interval from a to b. Let g be antiderivative of f, then so if we have that definite integral from a to b of f of x, then what we do, we basically calculate or we find the antiderivative, right? So g, and then we plug in the endpoints, right? So g of b minus g of a. And notice that here we don't have that plus c, right? We don't have that constant. It's because, right, so this will just give us the numbers, right? And we'll be subtracting two numbers from each other. So let's just look at an example. Well, anyway, so what does that mean, right? So basically, if we want to calculate the area of that under the curve, right, from a to b, we find the antiderivative, or we just do a simple, or we do a regular integral of this f of x, and then we plug in the endpoints, right? So we do g of b and g of a. Anyway, let's look at an example. Okay, so example 1, evaluate or find the area, right? So we have our curve, it's just y equals x. So let me write the problem, and then maybe I'll draw a picture of what's going on. Right, so that f of x is just x, right? So it's just y equals x. Right? It's just a straight line, a straight diagonal line. Okay, so here it is. So this is y equals x. And then this is 2, 4. Right, so what we need to do, we need to calculate this area. Right, so we could do it quite easily without calculus, right? And it wouldn't be too hard, right? Because it's just a regular triangle. Let me draw the triangle. Right, so we could calculate the area of this, right? Pretty easily, and then subtract from that the area of this, and that would give us the yellow area. Anyway, but let's so we'll do it in a moment. But let's see how that calculus, how that second, the fundamental. There's a second fundamental theorem of calculus. But let's look at that first part. Right. So the first part just says that I need to calculate antiderivative of that. Right. So I hope you remember how it went. Right. So it went something like this. If I have an integral of x to the n dx, right, to calculate that integral or that antiderivative, I add 1 to that exponent, so plus 1, and then I divide it by n plus 1. Okay, so let me write that formula here. So it's it's x to n plus 1. N plus 1. I hope you've done enough problems, right, that you remember how to do this, right? And then we had that plus c. But in our case, when we're calculating the definite integral, we won't be having that plus c. Okay. All right, so let's calculate it. Right? So I have definite integral from 2 to 4 from x dx. Right, so we use that formula. So we have x to the first power, so it's going to be x squared. And then divided by 2, right? Divided by that exponent. Okay, and then the way I do it, I just make a vertical line, right? And I write 4 and 2 over here, like this. So that means that I'm evaluating that function for 4, right? So it's going to be f of 4, or g, right, in our case, minus g of 2. Right, so that's what that fundamental theorem says, right? So I calculate the antiderivative, or I do the integral, right? That's the g, that's our g. And now I'm plugging in 4 and 2. So it looks like this, right? So I have 4 squared over 2 minus, now I'm plugging in, let me maybe do this, okay? Now I'm plugging in 2 minus 2 squared over 2. Okay, so that 2 went over here. So 4, right, goes over here. And that 2 goes over there afterwards. Right? So we end up with this just arithmetic problem. Okay, so we have 16 over 2. Right, so when we're doing those integrals, there's going to be a lot of difficult, it's not difficult arithmetic, but it can be quite labor intensive. Okay, so we got 6. Okay, so 6 square units. Now let's go back to those triangles, right? And just kind of verify it by calculating the area of the red one, right, minus the green one, and we should get the area of the yellow one, which is 6. Okay, so maybe just kind of, let me write it here. So area of the red triangle, right? So we have half, right? Then I have base times height. So base is 4 times height, and height is also 4. Right? And now I'm subtracting the area of the green triangle. So I get half. Right, so I'm looking at this. Base is 2, height is 2. So 2 times 2. Green, green, green. So 2 times 2. Okay, so we get 16, 8 minus 2, and we do get that 6. Okay, so basically, yeah, that's it. That's what that second, that's what the fundamental theorem of calculus says. And yeah, let's do more examples, right? Example 2. And it goes like this. Okay, so we have a curve, and it's a parabola. X squared minus 3. And again, let me start by showing you the picture so that you understand what you're actually doing. And yeah, and then we'll actually do it. Okay, so here's the graph. It's from 1 to 2. Here's the parabola. I should have... Right, it's just a regular parabola shifted down by 3 units. So this is -3. And then 1. This is 1. And then this is 2. Okay, so now we'll be adding these two, or evaluating, in a sense, right? What we'll be doing, we're evaluating the integral. So we're not really calculating the area. We could, right? We could calculate the area, but for now, we're just learning how to evaluate those integrals. So I'm guessing, well, I know, we're going to get a negative number, right? Because the area under the curve is bigger than the area above the curve, right? So I'll be subtracting, so this number will be negative, and this number will be positive, right? So this number, the negative number, is greater in a sense, right, than this one. Anyway, let's do that calculation. Okay, so we're finding antiderivative. So let's do that. All right, so I hope you remember that we can split it into two, right? Two integrals or two antiderivatives. So the first one, and we add 1 to that exponent here, and then divide by the result. Right? So it's going to be x to the third divided by 3. And here we have, so this is, and when you have a constant, you can think of it as 3 times x to the 0 power, right? Let me write it. Right, so I have some integral, let's have that 3. So think of that 3 by itself, right, that constant, as 3 times x to the 0. Now you have dx. Right, so now if you're looking at this, calculating this integral, you see that x, and I'll be adding 1 to that 0. Right, so I'll end up with 3x. And then if we were just calculating that regular integral, right, I would have to write plus c. But in our case, and I'm going to write plus c, right, because here it's just a regular integral. Anyway, let's go back to our problem. So calculating that antiderivative of -3, it's going to be -3x. And now I have that evaluation, right? So I have this, let me make it a little nicer. I have this 1, right? From 1 to 2. Okay, so I'll be plugging in first. I'll be plugging in 2, both places, and then plugging in 1. Right, so I hope you now you'll see, right, what the difficulty sometimes is. Right, so I'll have that first antiderivative, so it's going to be 2 to the third over 3 minus 3 times 2 minus, and now I'm plugging in 1, right, the green one. Right, so this is the yellow part. Now we'll be doing the green part. So I have x to the third, so that's going to be 1 to the third divided by 3 minus 3 times 1. Okay, so yeah, usually I won't be really doing this arithmetic, but for now, yeah, let me show it to you, right? So I have, what do we have? Let me keep it. Okay, so 2 to the third over 3, so that's going to be 8 over 3 minus 6 minus 1/3 minus 3. Okay, so 8 over 3 minus 6. Let's just find the common denominator. So it's going to be 8 over 3 minus, so that's, what is 6? 6, so 18 over 3. Right, so that's the first parenthesis, minus, and this is, what is that? So 1/3 minus 3, so that's, let me do it slowly. Why not? So 1 over 3 minus 9 over 3, huh? Right? Finding common denominator. So the first one is negative 10/3. And then I have plus. So 1/3 minus, I'm here, right? So I'm doing this. 1/3 minus 9/3, so that's 8/3, so plus 8/3. Okay, so we got, the answer is negative 2/3. Right, so in a sense, the hardest part of these problems, right, is kind of knowing what to do, right, obviously, but also then just kind of doing this arithmetic, right, this can be quite difficult. Okay, so let's do a couple other examples. So example 3. And again, evaluate. And we have something like this. So it goes from, this time it's a trigonometric function, 0 to pi of cosine x dx. Right, so we're thinking, what, right, so I have this trigonometric function. So we could be thinking, well, what, if I took a derivative of some function, what function would that be so that I get cosine x? Alright, so I hope you know what that is. It's going to be a sine function. So I have sine, right, sine of x. And then I need to evaluate it from 0 to pi. Okay, so I plug in pi first. So sine of pi minus sine of 0. Okay, so we get 0 minus 0, and that is 0. Okay, so that was pretty simple, right, if you know the trigonometric functions and their derivatives. But let's say we want to calculate the area. So calculate the area between the curve f of x equals cosine x and the x-axis. Right, so the process of calculating that integral, right, so the integral will be the same, but the way we think about it will be slightly different. Okay, so let's see. So first, let's start with the graph. Okay, and again, right, if you know how the function, how the cosine function looks like, graph of it, would be great. We're doing from 0 to pi. So this is pi over 2. And this is pi. And this would be 3 pi over 2. Yeah, so, you know, you can just, for practice, you can just sketch that graph between 0 or maybe negative pi over 2 to 2 pi. Okay, so you can pause the video and try, see if you can do it from negative 1 to 1. Okay, so I hope you've done it. The function will look like this, right? So for 0 I get 1 for cosine. Then for pi over 2 I get 0. For pi I get negative 1, 0 here. For 2 pi, I'm back at 1, right? Same thing as 0. And here I get 0, right? So the graph looks like this. Right, then I go down, up, right, and the graph keeps going. Okay, so now we need to calculate the area between 0 and pi, right? So we're here, this and this. Right, so now you see that the y, that area, or y that value, the value of that integral is 0, right? Because I'm basically subtracting this from that, right? So these two areas are the same. When one is positive, this one is negative, this one is negative, positive. When we add them together, we get 0. But if we want to calculate the area between the graph and the x-axis, right? So that's going to be this, right? It's not going to be 0. It's going to be something else. So let's try to figure it out. All right, so okay, now it's good. So what we'll do, we'll calculate the area of this, right? And then we add the area of this. Okay, so that integral will be slightly more complicated because I'll have two integrals, right? So the first one is going to be from 0 to pi over 2 of cosine x, right? So that's that first green area, and then dx. And then the second one, I should maybe color code it. So let me get rid of this. So let's say this one will be yellow and the other one will be green. Right, so this is the yellow, right, from 0 to 2 pi, from 0 to pi over 2, right, from 0 to pi over 2, and the other one will be from pi over 2 to pi, right, so this is pi. Okay, so let's do it. Now I go from pi over 2 to pi. Again, cosine x dx. Okay, so this is the green area. Okay, and again, right, the integral of cosine x is just sine x. Evaluating from pi over 2, or from 0 to pi over 2. Then I have minus sine x. This time I go from pi over 2 to pi. Okay, so let's see how it looks. I wonder if I can fit it in here. If I'm careful, I can. Okay, so here we go. So in parentheses, sine of pi over 2 minus sine of 0 okay, then I go minus sine of pi. No, I didn't manage to to fit it in there. Anyway, sine of pi minus sine of pi over 2. So minus okay. Yeah, this should be plus actually, right? We're adding those areas. So plus there. Okay, so what do we get? Sine of pi over 2, that's 1. Sine of 90, 1. Minus sine of 0, 0. Now I have plus. And here what I need to do, right? So I'm going to get a negative value out of this, right? It's going to be 0 minus 1. So I need to do an absolute value of that, right? Just kind of, then I'm calculating the area, so taking absolute value of this, of that value, of that number. So it's going to be 0 minus 1. saying absolute value and then I forget to put it. Anyway, so it's 1 plus 1. So the area under that curve is 2. Right, so it's the area under the curve and then above, right? So between the curve and the x-axis. Okay, so let's do another example with some trigonometric function. So example 4. We have something like this. So from 0 to pi over 2, sorry, pi over 4, secant square x dx. Okay, so antiderivative, and it's again, right, it's good to kind of have those derivatives in your head, right? So if I take a derivative of tangent x, right, I get secant square. Right, so this is an antiderivative of that, so that means if I take a derivative of this, I will get secant square. Okay, now I still need to evaluate it from 0 to pi over 4. So we get tangent of pi over 4 minus tangent of 0. Okay, so we get tangent of pi over 4 is 1, minus 0, tangent of 0, 0, 1. Okay, so that's our result. Yeah, so for now, let me give you a couple of problems to do. So practice. And it goes like this. So evaluate the integrals. Okay, so the first one is from 0 to 2, and the function is 6x. Okay, so problem number 2. And from 0 to 1. Yeah, so this time we have a different variable, but yeah, it doesn't really matter. dt, and here I have, this is to the second power. Okay. Yeah, so you need to kind of figure out how to do those integrals, obviously, or just be able to do them. Okay, the next one is from 1 to 4. Yeah, and the difficulty here, again, will be that arithmetic. And try to do, right, try to do that arithmetic. It's just, it's tedious, but it's just a good practice. It's good to do some of those problems and, and fight with them and whatnot. Okay, I'm trying to, okay. Again, the last problem, number 4. I hope I have it right here. It's from 0 to pi. And the function is 1 plus sine x dx. Okay. And yeah, so pause the video, do the problems, and here are the solutions. So the first one is 2. The last one is 2 plus pi. Then problem number 3. I have them solved here. I hope I solved them right. So that's the third one. Problem number 2 is 1/3. And problem number 1 is 12. Okay, so let me show you one more type of the problem. I hope you figure those integrals out. And this one involves absolute value. So Problems with absolute value are always interesting. So find definite integral. It should be maybe value, right? Find the value of the following integral. Absolute value of x minus 3 dx. Yeah, there's a couple of ways to do it. We could rewrite this this function. What is the easiest way? Let me maybe show you solving this based on definition. Okay, so if I have a definition of absolute value, right, it looks like this. So if I have absolute value of x, that is x if x is greater or equal than 0, right? And then it's negative x if x is less than 0. So so this is the general definition. Let's look at our particular function, which is x minus 3, right? It's not just absolute value of x. Okay, so this is okay, so where are we? We're here. Right, so I have absolute value of x minus 3. So that means that I have absolute value and it's moved to the right by 3. All right, so let's graph it. So 1, 2, 3. So we're here. And here's the graph. And it's just that regular absolute value v. Let me try to make it better. So erase this. And so I go from here. And it's a like 45-degree line. Okay, but I have slightly more space there. Okay, so this is 3. Now this is 4. Right, so I'm calculating that area or evaluating the function from 0 to 4. Right, so this is 0 here. Right, so it's gonna be this area. Let me maybe do it this way. Right, so I'm calculating technically this area or evaluating that integral, right, for this. Yeah. But in reality, right, I'll be adding this and this. Okay, so now when I look at the definition, it'd be nice if I could see it when I'm writing it. Okay, I got it, kind of. All right, so now I have that x minus 3, right? So using this definition of absolute value, by analogy, we would write, right? So it's going to be x minus 3. If that x is greater or equal than 0, right? And then, okay, so now I'm looking at this this graph, and it's actually not going to be. And because this x minus 3, let me write it here. So that's this graph. So y equals x minus 3. And this one, the other one is this one. Right, so that's going to be y equals, and then negative, right, in front of x minus 3. It's going to be negative x minus 3. Right, so in reality, this is going to be this one. Right? It's going to be negative x plus 3. Right? That's kind of what it is. Anyway, let's go back to this. So here I have x minus 3 if x, and it's going to be between 3 and 4, so greater then 3, and less than 4. Okay, and then the other one. So this one is, let's do it this way. Just kind of keeping it aligned with the definition. And here x is from 0 to 3. Right? So x from 0 to 3, between 0 and 3. Okay. So we have that, right, the definition of that absolute value. So now let's use that information to write those integrals, right? So this is what we need to do. I think maybe I'm making it a little bit unnecessarily too complicated, right? Because I'm just looking at it. I could just look at this, right? So I'm doing integral from 0 to 3 for this curve, and then integral from 3 to 4 of this curve, right? I don't need this whole discussion of definition of absolute value. Anyway, it's there. Let's leave it there. So the first integral was that one, right? It's this one. So it's gonna be from 0 to 3, and it's negative x minus 3 dx. And then I'm adding the other one. The other one is from 3 to 4 of just x minus 3 dx. Okay. So first step, we find those antiderivatives. Right, so antiderivative, right, of, let's take this negative out, right? We'll have antiderivative of x and this, and then we'll have just the same things. The same because this is the same as that. Okay, so I have a negative in front. So now I'm doing the integral of this, right? These two terms. So the first one is x squared over 2 minus 3x. And evaluating it from 0 to 3. Then I have plus, and this is the same thing, but evaluating it for different endpoints. 3 to 4. And yeah, I'm going to write it, and then I'm just going to give you the solution. Right, so we have negative. So I'm plugging in 3 first. So 3 squared over 2 minus, okay, so we have 3 again, 3 times 3. Okay, this minus is in front of the whole thing. Now I'm plugging in 0. Okay, so I have 0 squared over 2 minus 3 times 0. And it's just going to be 0. Right, so that's that first part. This is here. Now this part is going to come next. Right, so now I'm plugging in 4. So 4 squared divided by 2 minus 3 times 4 minus, I'm plugging in 3. So 3 squared over 2 minus 3 times 3. Okay, so I hope I did it right. I hope you guys have the same thing. Okay, so what I finally got out of this calculation is 5. Okay, so that's the answer. And yeah, let me give you a problem for practice. And then that's going to be it. So practice. This is T. Okay, so evaluate definite integral. Just one problem. Integral. And here's the integral. So from 0 to 5. It's basically it's a very similar problem. 2x minus 5 dx. Okay, yeah, so pause video, try to figure it out. And yeah, what I have here for the solution is 25 over 2. 25 over 2.